Okay, so I'm going to coach you through your responses to the homework I've set. State 3 essential features of recursion. Well, every recursion needs to have a base case, otherwise it won't ever stop. The rest of the recursion function is called the general case. That's a general case which is used to keep calling itself. So for example, if we have a function which was add, and we're going to do y, z, and our function is called add, so def add yz. This would be part of the general case, which will be used to call itself again recursively. And the whole point is, every time we call it, it moves towards our base case, which is most of the time 0. So every time we recursively call, we want to move one step closer to our base case. So once we reach the base case, so is it base case? Yes. So once we've reached it, we can then simply unwind our data. So if we've got like 4, 3, 2, 1. Once we reach our base case, we then empty out our stack to give us our final result. Let's call it total. So again, the way recursion works, we have a base case, we have a general case. The general case is what's being used to keep calling itself, which moves one step towards our base case every time. The idea is that once we've reached our base case, which is our stopping condition, we then unwind the stack. Why is a stack suitable for recursion? Well, it uses LIFO. Every time we do a recursive call, so we add to the stack. So 1, let's do 4, let's do 7, whatever it's going to be, 10. Once we reach our base case, we can then, so as our function ends, we can pop last in, first out. So goodbye, 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 goodbye. So it allows us to unwind. A stack allows us to unwind, to maintain the order we need to then give us our end result, which could be like 21, whatever it's going to be, 22, which we then return. Queues, remember, work backwards in terms of its FIFO, so that ain't going to work. Two other ADTs other than the stack, where you can mention the queue, you can mention linked list, binary tree. There are way more. The example, for some reason, have just left these. But whatever. Okay, so what you need to do for this question was simply create a function called add integer, which calls stack full and returns a message. This is what stack full looks like, so we know that we're dealing with a Boolean. Now you might need to practice your pseudocode. So my advice is look at my year 12 playlist where we've got loads of pseudocode examples. For those of you who don't need to practice your pseudocode, let's have a look at the solution then. What we have is our function header, add integer, we've got our new number being added, and we need to put the data type. But remember, we also need to put what data type is being returned. That is key. So in this situation, we're returning a string. Returns an appropriate message. Okay. The function uses the variable top of stack to represent a pointer to the most recent position used on the top of stack, and the variable max to represent the maximum of stack. Assume top of stack and max are global variables. Fine. So we need to check to see whether or not, when we're adding a new data item, if the stack is full first. That's easy. We've done that loads of times. So this is saying if stack full. just like that. That is, I wouldn't want you to do it that way. I would rather you would have a variable first, we'll call it result, equals stack full, and then simply do the if on result. So if result, which basically means if true, or you can do if result equals true. Return the message, the stack is full. If it's not full, what we need to do is increment the top of stack. We're adding 8. 8 gets added, top of stack is now going to be here. We then put our new number into that top of stack, so really what we should have done is this. Top of stack was here, we increment it to be here, we then put 8 inside of it. Then we return the message, item added. End our if, end our function. Easy, simple. That's all it needs to do. Returns an appropriate message if it's full or added. That's what means appropriate message. So we need to check if it's full. If it's not full, we add it. If it is full, we don't. Okay, this next question is really easy. You just need to match up the programming paradigms with their descriptions. So, declarative programming, which we know is all about rule-based. We also know that the whole point of it is to get to a goal, a result. Programs that specify desired result and how to get to it. That is declarative. Are there any other for declarative? Rule-based, no. Rule-based, no. Rule-based, no. Rule-based, no. Imperative, which is procedural programming, which is basically normal programming without objects and procedures. Sorry, without object-oriented programming. So, let's have a look. No. 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 Programs with a sequence, with or without procedure call. Yeah. So you can use procedures, or you don't have to use procedures. It's just like normal code. Low level, using instruction set. Yes, well that's obvious. Low level, programs based on events such as user actions, sensors, inputs. No. Low level, program using, well it says one line, so let's just hold it there. Okay, and the final one, object-oriented programming. What does he say? Inheritance, encapsulation, polymorphism. Boom, done. Okay, let's just get straight onto this. Write programming code to declare the class picture and its constructor. Well, it says do not write any other methods. So from an example's perspective, that is all you need. You need the class, you need the constructor itself, and then we need the attributes with their data types as comments. Done. So we're basically doing this. Nice and easy. The next question, before get methods, return the associated attributes. For example, get description, say blah, 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 blah. Easy. There are get methods. It's basically asking us to do this. Nice and easy. Okay, then we've got to do the set description. So set description takes a new description as a parameter, so we need to have a parameter. It writes this value to the appropriate attribute, takes the new description, and writes the value to the description. Well, that's dead easy. And here we have it. We have the set description. We then have our parameter. We then have our attribute being assigned the value from the parameter. So we've done our set description. Remember, set, we don't need to print anything. It doesn't tell us to. Write program code to declare an array of type picture with 100 elements. So there are different ways of us doing it. So the example would have gone with this method where we just set a nice 1D array, we loop through 100 times. Each time we loop, we add to the array our class picture, where we're creating our object, and we're passing into our constructor empty, 0 for description, 0 for the, sorry, not 0 for description, empty for the description, 0 for the height, 0 for the width, and empty for the color. Because we're not actually assigning it any actual values yet, we're just getting it ready to be used. So we're making basically 100 of these in an array, all ready for us to be used, like we normally do when we're setting up nodes. Empty nodes ready to be used for like a binary tree or stack or whatever. Okay, so what we need to do now is we need to be doing a procedure in the main code, which is going to, or should I say a function, which is going to open up a file, read the data from a file, create a new object of type picture for each picture, raise each object to the array, raise an exception that the file can't be found, etc, etc, etc. And there are different ways you can do this. Let's look at the examples version. Is passing in the array. We're opening up, or we're storing into a variable of a file name, counter equals 0, because I'm guessing we're using that for the count and return the number of pictures in the array. We're then opening up the file. It's now going to take the first line from the file and turn it into lowercase and get rid of the /n. You could have also used read lines plural and put it into an array and then for each line strip it, etc, but whatever. Using a for loop. They're using it line by line, so whilst the text file doesn't have an empty description, we're going to enter a width, let's say 8, a height, let's say 2, a frame, which is blue. It's then going to add to our array, which we made earlier. So if you remember, we did, one second, our array called picture array. Remember that we had it, how many was in there? 100? I can't remember. And we had like 100 classes ready to be used as objects. So I'll rephrase that again, we had 100 objects ready to be used. So all we're simply doing is we're putting in our data, so into object 1. Let me just move this across a little bit so you can see it. Oh my gosh. Okay. So this is position 0, position 1, we've got another one of those, etc. So we've got, remember, 100 of these. And we're putting in the values of the description, whatever the description is. We're putting in 8, we're putting in 2, and we're putting in blue. The counter goes up by 1. And then we get the next line. So readline will automatically get the next line. So we get the next width, the next height, etc. This keeps going until in our text file, there's nothing left. It's empty in our description. The loop will finish, the file closes, we have our except, file couldn't be found, and we're returning, because it tells us to return the number of pictures in the array, and also our array itself. Because we're passing in the array, we need to update our array by passing it back. So we take in all our changes from a text file, we pass it all back to the main code. Yes, there are other ways you could have done that. As I said, you could have done a for loop for item range of the list if you're using read lines. You then don't need to use a counter either, because it'll just go, you can just use length, or should I say len, because if you put it into a list, you're literally taking every single line that's there, putting it into a list, counting how many items are in that list, and that tells you automatically. It'll stop at the last one. So again, different ways you can do this. Okay, so for this next one, The main program calls the function read data, write the main program code. So let me just make this a bit smaller. That's easy. This is our read data. We're passing in our array. These are the results from the function we've just made. That's it, it's done. We're calling read data, we pass in the array, we open up the file goes through each line, putting it into an object, it'll then loop again, put it into the next item in the array, and then again into the next item in the array until the file's over. At the end, it'll tell us how many pictures in the array, either using count or len, depending on what you did, and it returns also the brand new picture array with all the updates made. Easy peasy. So also in the main code, we need the user to input their requirements for a picture. So basically we need them to be entering this information here. The user will enter the color of the frame, the maximum width, maximum height, great. The program will then search the array of pictures. So we made that array called picture array. And output the picture description, the width, the height of any picture which matches the requirements. If I search for, I don't know, blue 1, 1, it will search the array, is there blue 1, 1? Width, height. If yes, great. What I'm going to do now is display the description that belongs to that photo. The program should allow the user to input the color, in any case silver, silver, or silver. So that means that we're going to have to basically be using dot lower or dot upper. Most likely it'll be dot lower to make it all match with what we've got on the array. Edit the main program so it does this. Well, this gets the color, dot lower, the width, the height. So like I said, let's imagine 1, 1. It then does a little print message saying we're going to search for you, blah, 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 blah. For some reason we're using Z. For Z in range 0, this really should be length. Oh no, actually, I lie. This should be the number. This is what we got from the previous challenge where we had to get the number, remember, through length or through a count. We returned it to the main code, which is why we did that in the first place. So if you did length here, that would be wrong. Well, it would be right, but you're then not using the variables which they provide for us. They asked us in the previous challenge to do number of pictures in an array, so we need to use it. That's what it's used for. Keep that in your brain. It's then going to check if picture Z dot get color. So remember, when we're in the array, it's an array of objects where it's got frame color. I'm going to do FC, max width, max height, and description. And remember, to get that information, we still have to use our methods of get description. In fact, these ones. So if we want to see what the color is of in our array, so let's imagine our array is 100. So we've got 100 of these objects. So let's do 1, 2, 3, 4, 5, 6, blah, 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 blah. So 100 of those. And in the first one, position 0, we've got frame color, and it's gold. Sorry, silver, let's do. To check to see this, we need to use get. So in position 0, we're looking at the color. Does it match what we're searching for? The frame color. Well, we're searching for blue, so it doesn't. So let's imagine the next one, position 1. It was blue. Yes, it matches. So now what we're going to do is we're going to check the width. We're going to use get width. We're going to compare that to the, if it's less than or equal to the maximum width. If it matches, we're then going to get the height, and is it less than or equal to the maximum height? So we're not checking to see if the width and the height match, we're seeing if it's in that range. That's why we're entering the maximum width, it could be in the maximum height. Hence why we're using less than or equal to. If all of these match, we then need to display the description. To display the description, we need to use print. We need to use the array, we need to use position, and we need to get the description. But it also wants us to display the other information as well. So You don't really need to do this bit like this, but still. We're turning to string, array, z, get width, so we're getting the result of get width and turning that into a string, and same with get height. And that is that. We have now successfully gotten to enter in the information here. We search the array. This is how you access the array. Like normal, but instead of doing like picture z dot max width, or say it wouldn't be max width, it would just be width. We have to use get to get the value because we're using encapsulation. Okay.